All right, let's dive in. Today we're looking at a breakthrough from Nvidia that could totally change how we find, well, pretty much anything. What if you could search through thousands of images, charts, and documents, not with some clunky keyword, but by just describing what you're looking for? Let's get into it.
I mean, really think about that for a second. You're looking for that one specific chart, and you know it's buried somewhere in a year's worth of presentations. Your typical search bar? It's completely useless because it can't see. But what if it could? What if you could just ask your computer for the exact thing you're picturing in your head? Well, that's the big problem Nvidia is tackling here. And this isn't just some abstract idea. Look at this query right here. Find all slides with revenue charts from Q3. Now, for anyone who's ever worked in a big company, you know that's an absolute game changer. It means you can stop manually scrubbing through hundreds of slides. The AI can just find the specific chart you need, and it can do it instantly.
So, how on earth is this even possible? Well, it's not actually magic, but it is a fundamentally new way of teaching an AI how to see. Let's break down the core idea that makes this whole thing tick.
Okay, this slide really lays out the key difference. Think about the old way, on the left. An older model looks at a complex image and pretty much slaps one vague digital summary, or embedding, on the whole thing. It's kind of like describing a beautiful, detailed landscape with just one word, countryside. Not very helpful, right? But Nemotron-ColEmbed on the right is completely different. It creates a whole bunch of precise reference points, an embedding for the tree, another one for the cloud. You get the idea. It creates this rich, searchable map of the image, not just a blurry label. So the technical term for this whole multi-point approach is ColBERT-Style Late Interaction. The key thing to understand is that it generates separate vectors. Think of them as digital descriptions for every important part of an image. So a chart might get a vector for its title, another for the x-axis, and maybe one for a specific data point. That way, when you search for the word revenue, the AI isn't just guessing. Nope, it's matching your word directly to the specific part of the image that is the revenue data. It's incredibly precise. So that's the theory. But does it actually work in the real world? Well, the source material gives us this fascinating demo in a field where there is absolutely zero room for error, medical imaging. This is where precision is everything.
Okay, so the test kicks off with a simple but very specific text query. The goal is to find the one image that perfectly matches this description from a set of really distinct medical pictures. And here are the images it has to pick from. You've got an image of an eye, a slide at the cellular level, and the cross-section of skin. I mean, they're all medical, sure, but they're incredibly different. For the model to get this right, it has to understand the tiny details that separate one medical specialty from another. And the result? Bam! A perfect match. As you can see right there in the table, the dermatology image got the highest similarity score by a country mile, 21.13. The others weren't even close. This is just a brilliant, simple way to show the model's precision in a field that's super specialized. And get this, that wasn't a one-off. The big takeaway from the demo is this number right here, 100% accuracy. Every single medical query was matched to the correct image. In a high-stakes field like this, that's not just impressive, that's the proof of concept. Okay, so a controlled demo is one thing. But how does this model actually perform out in the wild when it's up against the competition? To figure that out, we've got to look at the official industry benchmarks. This number, 61.42, that's the model's score on something called the ViDoRe V3 benchmark. And trust me, this is not an easy test. It's designed specifically for real-world business uses across different languages and all sorts of document types. Nailing a score this high is a really big deal. And this chart really puts that score into perspective. See the two bars on the left? Those are the Nemotron models. They are sitting right there at the top of the leaderboard, clearly outperforming other top models in the space. The message here is simple. This isn't just some cool concept. It's a legitimate top-tier performer. So, we've seen how it works and how well it works. Now, let's talk about the big question. So what? What does this technology actually mean for the future of search and for how we interact with our own data? This kind of technology really unlocks three major advancements. First is something called multimodal RAG, which is a mouthful, but really it's a fancy way of saying you can literally have a conversation with your documents. You can ask them questions about the charts and images inside. Second, it's going to power way more powerful multimedia search engines. And finally, this is the key to creating truly smart AI assistants that can actually see and understand the visual world around them. And really, that's the big idea here. This technology changes our data from just a static library of files into something we can have a real dialogue with. It's a fundamental shift. So I'll just leave you with a question on the screen. When your documents can finally see, what's going to be the first thing you ask them?